So it says that a 52 kg circus performer is to slide down a rope that will break if the tension exceeds. So T max is 425 Newton. So that's given. So the first part is what happens if the performer hangs stationary on the rope. When the performer is hanging stationary on the rope, the tension T is equal to mg, that is 52 times 52 is the mass of the performer, so 52 times 9.8, that is 509.6 Newton. This one is bigger than T max. So what happens is the rope will break. Now the second, so it cannot withstand, the performer cannot just hang on the rope. So at what happens? At what magnitude of acceleration does the performer need to move to avoid breaking the rope? Does the performer, I don't know, at what magnitude of acceleration does the performer need to slide down just to avoid breaking the rope? Basically that's what the question is. It's written improperly. So there has to be an acceleration with which the performer has to keep climbing down or sliding down so that the rope can withstand the tension. So when the performer is going down, that's ma with an acceleration of a, and his weight is mg and rope tension is t. So mg minus t will be equal to ma. From here we need to find the value of a with which the performer can go so that it just doesn't break. So that would be the minimum acceleration, because if the performer goes slides down with a less amount of acceleration, the rope will break. So anyway, T is equal to, then it will be 52 times 9.8 minus 425, so that's 509.6 minus 425. So A becomes divided by 52, that is 1.6 meter per second square. That's the value of the acceleration. So we can rewrite the tension formula like this: mg minus ma it becomes, if we take the tension on the other side and ma on this side. So now we can see, for T to be, this one to be less than T max, or at least less than equal to T max, what we need to have is ma to be of this certain value, so that this one is less than mg, basically not too much less than mg, because if this is very small, then mg minus ma will be smaller than T max. As a result, the rope will break basically. So mg minus a basically, so that's what needs to happen. This one has to be at least like of that value. So if a is 0, we have seen that it is broken. If a is less than 1.6, it's still, the rope will break down basically. So that's the minimum acceleration, or that's the acceleration with which the performer has to slide down, keep sliding down, which is a is equal to 1.6 meter per second square.